Okay, this week, this week 10. Week 10. So, I'll teach you about a moment about origin, and a moment about me. So please refer to page 123. So by definition, moment about mean. So a moment about origin is indicated as mu prime j equal to expectation of x raised j. So this will give me the expectation of x raised j is a summation of for all x raised j fx. So j for j equal to 0, 1, 2, 3, ... This is referred to a discrete random variable. Discrete random variable. Now for the continuous random variable, moment about origin or mu prime j is equal to expectation of x raised j, and for the continuous random variable, moment about j is equal to mu prime j is from negative infinity to infinity, the integration x raised j fx dx. The other part is a moment about the mean. Moment about mean. Okay. And by definition, moment about mean, we just put mu sub j equal to expectation of x minus mu raised j. This is equal to summation for all x minus mu raised j fx. For j equal to 0, 1, 2, 3, ... Okay. And this is a case for a discrete random variable. And for a case of a continuous random variable, mu sub j or moment about the mean is equal to expectation of x minus mu raised j integration from negative infinity to infinity x minus mu raised j fx continuous random variable. the concept of the concept of moment is applied in the statistics, and other than that, it also apply in the physics. So if you refer to concept in physics, the moment, just imagine that if we have spanner and nut. Let's say we have a nut. We have a nut is like this. It's nut. And then we have a spanner. We have a spanner here. Spanner. This spanner is to open this nut, to loose or to tighten this nut. Okay? You open the nut here. If you open the nut here, or you open the nut, you tighten the nut, or you loose the nut, the force here, and this is referred to the concept of moment. It's called a moment. It's a moment. The force here, or the relationship between the force and this nut, you open the nut here, the concept here, the relationship between the force and the energy used to open the nut here is known as a moment. This is a concept in physics. And this is the what I call the pivot. Pivot. It's called pivot. The relationship between pivot and the force here is known as a moment. This is a concept of moment in physics. Whereas moment in statistics, we have, let's say we have a moment about the origin. We find the expectation of x minus by the origin is 0 raised j. So that's why we have expectation of x raised j. This is a moment about the origin. Expectation of x minus mu raised j. This is a moment about mean. This is a moment about origin. Okay, look at example 5.12. Example 5.12. Example 5.12. So I want to find the moment here. So given that the continuous function, this is a continuous function, fx, for the case of continuous function, so I have here fx is equal to 5 minus x over 8, 0 elsewhere, and x is between 1 and 5. So I want to find the moment about the origin. Moment about the origin. So by definition, moment about the origin is a expectation of x raised j. So this is because of since it's continuous function, so we integrate here the integration of from 1 to 5 x raised j fx x, and here is equal to integration 1 to 5 x raised j. Then the function that is 5 minus x over 8 dx. Now if you integrate this one, So I will try to simplify here. Here become integration of from 1 to 5 x 5x raised j. If you integrate here, become now it become 1 over 8. The integration there is 5 x raised j plus 1 over j plus 1 minus by x raised j plus 2 x equal to 1 and 5. So this is equal to 1 over 8 5 multiplied by 5 j plus 1 over j plus 1 minus by 5 j plus 2 over j plus 2, then minus by 5 multiplied 1 j plus 1 over j plus 1, then plus by 1 j plus 2 over j plus 2. Okay. So you have here 1 over 8. So 5 j plus 2 because of 5 raised 1 multiplied by 5 raised 1 here is 5j plus 2 over j plus 1 minus by 5j plus 2 over j plus 2 minus by 5 because of 1 raised j plus 1 is equal to 1 over j plus 1 plus by 1j plus 1 raised j plus 2 is equal to 1 over j plus 2. This is a general form of expectation of moment about the origin x raised j. Moment about the origin. Now, the question there is, they ask you to find 3 moments, the first 3 moments about the origin and about the mean. So, by definition, okay, the result for moment about the origin, expectation of x raised j, this is a moment about origin, is equal to 1 over 8 5 j plus 2 over j plus 1 minus by 5 j plus 2 over j plus 1 j plus 2 minus by 5 over j plus 1, then plus by 1 over j plus 2. These are expectation of x raised j, or moment about the origin, the general form. So we want to find the first moment. The first moment is we need to find mu prime 1. This mu prime j. This is mu prime j. This is mu prime j. Moment about the origin, mu prime j. Mu prime sub j. Prime sub j. Now I want to find the first three moments. You need to say I want to find mu prime, the first three moments about the origin. First three moments about the origin. So we need to say I want to find mu prime 1, then I want to find mu prime 2 and mu prime 3. These are first moment, second moment of origin, and these are the third moment about first moment about the origin, and here is this is second moment about the origin, and this is a third moment about the origin. So I want to find mu prime sub 1, mu prime sub 2, and mu prime sub 3. So the general form of mu prime j is 1/8, 5j plus 2, and so on and so forth. So mu prime sub 1, now for mu prime sub 1, we just substitute j is equal to 1 here, because we have j is equal to 1 here, we have 1/8, and j is equal to 1 here becomes 5, 1 plus 2, 5 raised 1 plus 2, 1 plus 2 over 1 plus 1 divided by 5 raised 1 plus 2 over 1 plus 2 divided by 5 over 1 plus 1 plus by 1 over 1 plus 2. So we have here 1/8. So 5 raised 3 is 1 to 5 over 2 divided by 5 raised 3 is 1 to 5 over 3 divided by 5 over 2 plus by 1/3. So the final answer here is equal to 1/8. 1 to 5 divided by 5 is 1 to 0/2 divided by negative 1 to 5 plus by 1/3 is negative 1 to 4/3. Now, if you solve this one, the answer will be 2 1/3. 2 1/3. Okay, this is the final answer. Then I want to find mu prime 2. Mu prime 2. So mu prime 2 is equal to, so 2 plus 2 over 2 plus 1 divided by 5, 2 plus 2 over 2 plus 2 divided by 5 over 2 plus 1 divided by 1 over plus by 1/2 plus 2. So this is equal to 1/5 raised 4 over 3 divided by 5 raised 4 over 4 divided by 5/3 plus by 1/4. So if you solve this thing, we get 6 1/3. 6 1/3. And the last part, I want to find the moment about the third moment, or mu prime 3. So mu prime 3, mu prime sub 3, for the third moment about the origin, mu prime sub 3 is equal to, so I just substitute j equal to 3 into this function. So I have 1 over 8, 5 raised 5 over 4 minus by 5 raised 5 over 3 minus by 5 over, sorry, here is 5, 3 plus 2 is equal to 5. 5 over 4 plus by 1 over 5. And if you solve this one, you get 19 over 5. This is a final answer for the third moment about the origin. Okay, now so mu prime sub 3, the final answer is mu prime sub 3 is equal to negative 20 116 over 135. Now then we go to next part is moment generating function. Moment generating function. Now the moment generating function is to determine the moment of certain distribution. So to determine the moment of the distribution, we use to determine moment of the moment about the distribution. So we use moment generating function. Okay. Now, by definition, the moment generating function m sub x t is equal to this m sub x t is equal to expectation of exponents raised dx. So this is equal to summation of e dx fx or x is the case of discrete random variable. And for the continuous random variable, moment into function mxt is equal to expectation of e dx is equal to integration from negative infinity to lower limit to upper limit e dx fx dx. This for continuous random variable is equal to 5 1 over 4 raised x e dx for x greater than equal to 1 or 0 elsewhere. 0 elsewhere. Now I want to find the moment generating function mxt. So mxt, the moment generating function for this function is equal to, and since this is a discrete case function, so I have to integrate So I have to get the summation of x from 1 to infinity, because we start at 1 and 1 to infinity. So the function there is this is the function. The function is 5 1 over 4 raised x. This is the function 1 over 4 raised x. Now, by definition, mxt is equal to expectation of e dx. Expectation of e dx. So I want to find the moment universal of expectation. E dx is so e dx fx. So this is equal to, you solve this one, you get summation of x from 1 to infinity. So at e dx 5 multiplied by 1 over 4 raised x. Now if I solve this one, we get, if I add all these things, you get the first one, I substitute for x is equal to 1, I have, so the common factor here is equal to 5, so just bring out 5, the common factor. So then I substitute x is equal to 1, 2, 3, and until infinity. So if I substitute, when x is equal to 1, I have here e raised 3 multiplied by 1, or et 1 over 4 to the power of 1. There is x is equal to 1, plus by s is equal to 2 e 2t multiplied by 1 over 4 is 2, plus by e s is equal to 3t 1 over 4 raised 3, and so on and so forth. Okay, the infinity. So if you look at this series, you look at this sequence, so we can see that this is similar to geometry progression. This is a geometric progression. This is a geometric progression. Now, if for the geometric progressions, the ratio here, so every time increase by 1 over 4 et, increase by 1. So in other words, your R here for the geometric progression, this series or geometric series, this series is increased by 8 et 1 over 4, then et 1 over 4. If you multiply et 1 over 4 with et 1 over 4, you will get e 2t 1 over 4, then e 3t 1 over 4. Meaning to say the ratio here, R here is equal to 1 over 4 et, 1 over 4 e raised t. And a here, the first term here is a is equal to, the first term in this part, first term here is equal to, if you multiply 5 here, is a is equal to 5 multiplied by e raised t 1 over 4, first term. In other words, if you want to find the value here up to infinity, we put here is s infinity. So here is equal to s sum for up to infinity, or s infinity. So S infinity by definition by the formula, S infinity is equal to A over 1 minus by R. Okay, please refer to geometric series or geometric progression. So S infinity, the sum up to infinity is A over 1 minus by R. So since we know that our A is equal to, so this can be solved as well. So this can be solved. So put here, so S infinity or summation for x from 1 to infinity of this function, e dx fx equal to, so a1 minus by r. So your a is 5 e exponential to the power t multiplied by 1 over 4 divided by 1 over 4 multiplied by e raised t. So if you solve this one, we get the answer will be, the answer here is equal to, so if you solve this one again, this one again, you can solve this one and 1 equal to 1, e raised 3, e raised t to power e raised 3, e raised t divided by e raised 3 is equal to 1, so the answer here is equal to 5. So these are how we solve the moment function. Okay, we go back to our previous example. Okay. We'll go back to our moment about mean and moment about the origin. So I want to solve a few examples here. The moment about mean and the moment about origin. Moment about mean, moment about the origin, and moment about mean. So I want to solve, please refer to question example 514, example 5.14. Now, let's say I have this function. This is we call the a discrete function. So given that my fx is equal to 1 over 2 and 1 over 2, here is x is equal to negative 3 and this part is x is equal to 3. So I want to find the mu prime 1 moment about the first moment about the origin, mu prime 1, and then I want to find mu prime 2, and the last one I want to find the standard deviation, sigma, the standard deviation. So mu prime 1 by definition, you can use this method. So you can use the previous example just now. You try to find mu prime j. Okay, you try to find mu prime j. Let's say I try to find mu prime j. Mu prime j is equal to mu prime sub j is equal to expectation of x raised j. So expectation of x raised j is equal to summation for all x raised j fx. So here is, since we have 2x, so summation for x is equal to negative 3 and 3 x raised j, and fx is equal to half. So this will give me the answer of 1 over 2 negative 3 raised j plus by 1 over 2 3 raised j. This is the general form mu prime j. Now if I want to find mu prime 1, so mu prime 1 mu prime 1 is equal to, just substitute 1 here, so I'll get half multiplied by negative 3 raised 1 plus by half multiplied by 3 raised 1. So this will give me the answer of negative 3 over 2 plus by 3 over 2 is equal to 0. This is how we solve this one. And the second one, since my mu prime j is this function, mu prime j is this function, so mu prime 2, I just substitute into this function, we get half negative 3 raised 2 plus by half 3 raised 2. So here we could have 9 over 2 plus by 9 over 2 is equal to 18 over 2 or equal to 9. So that's why the answer for the second one is equal to 9. And mean, variance, standard deviation is equal to this A, and B, and C. I want to find the standard deviation. The standard deviation is equal to the square root of the variance. So first of all, we find the variance. So variance is equal to expectation of x raised 2 minus by the expectation of x, the whole thing here is 2. So x raised 2 is a by definition, x raised 2 is a mu prime sub 2 minus by expectation of x is a mu prime sub 1 square. So mu prime sub 2 is equal to 9 minus by mu prime sub 1 equal to 0 is now. We have 0 is now 0 square. So 0 square is equal to 0. Or in other words, variance equal to 9. Okay. Now, if you want to find the standard deviation is the square root of variance, so square root of 9 equal to 3. That's how we solve equation. Okay, I have a few questions here. Okay, I have a few questions here. So I have example 5.2. Sorry, before that we go to the last example, example 5.15. The last example is example 5.15. Example 5.15. Now, given that fx is this is a continuous function. So, given that fx, a continuous random variable, continuous function. So, fx is given as 1 over the exponential log is exponent, and 5 1 over x for x in between 1 to 5 and 0 as well. Now I need to find mu prime j. Then also I want to find sigma square. So I want to find mu prime j. Then I want to find the variance. So in other words, by definition, the variance is equal to expectation of x squared minus by the expectation of x squared. Now, expectation of x squared is a mu prime 1, mu prime 2. Expectation of x squared is mu prime 2. Then expectation of x is mu prime 1. the first moment about the origin, this is the first moment about mean. Okay, so this is very important. So in other words, we need to find mu prime 1 and mu prime 2. So to get this one, you can solve, you can use the formula, you can use the general form, mu prime j, okay, mu prime j is equal to integration of x raised j, the function fx dx, so 1 to 5. So this will give me the answer of, if I integrate this function, then just put here 1 to 5 x raised j, fx is 1 over log this exponent 5 1 over x dx. So if I simplify this thing, we get 1 over 5. Now x raised j multiplied by 1 over x, this is equal to x raised negative 1. 1 over x is x raised negative 1, so xj minus 1, 1 over log this exponent 5 dx. Since 1 over log this exponent 5 is a coefficient here, so you can 1 over log base 5, log exponent, log base of exponent 5, the integration of 1 to 5 x raised j minus 1 dx. So we start to integrate this one. So this will give me 1 over log base exponent 5. So the integration of this one is j minus 1 is xj x raised j over j. So substitute for 1 to 5. So I have here 1 over log base exponent 5 x raised 5 over 5 minus by x raised 1 or 1 over 1. So x raised 5 over 5 minus by x. This is a mu prime j. Now if I want to find the variance here, the variance here is mu prime 2 minus mu prime 1 square. So mu prime 2, now mu prime 2, you just substitute 2 into this function here, 1 over log this exponent 5. So x is equal to, sorry, this is wrong. This should be, here should be 5 raised j, 1 over log this exponent 5 raised j over j minus by 1 raised j is equal to 1 over 1 minus by 1. 1 raised j over 1 is equal to 1. Because of 1 raised j is equal to 1, 1 over 1 is also equal to 1. So this is the final answer. Okay. Now, so mu prime sub 2 is 1 over log base exponent 5. So substitute j equal to 2 here, 5 raised 2 over 2 minus by 1. So if you solve this one, you get 25 over 2. Okay, 25 over 2 minus by, so here is 1 raised j is equal to 1 over j. So here is 1 over j is equal to 2. So if you solve this one, it's 1 over log this exponent 5 multiplied by 25 minus by 1 is equal to 24 over 2 or 12. 12 over 24 over 2 or in other words equal to 12. So mu prime sub 2 is equal to 12 over log this exponent 5. Okay. Now we substitute here into this function. So I have here 12 over log base 5, log base exponent 5 minus by. Now I need to find mu prime sub 1. So mu prime sub 1. Now if you substitute into this function, this equation, so mu prime sub 1 is equal to 1 over log base exponent 5. 5 is 1 over 1 minus by 1 over 1. So we have 5 minus 1 is equal to 4. So the answer is 4 over log base exponent 5. So substitute here 4 over log base exponent 5. So this is the final answer. If you solve this one, you get, if you simplify this thing, you get 12 log base exponent 5 minus by 16. Minus by 16 over log base exponent 5 squared. This is our answer for example 5.15. So I want you to do the exercise 5.2. So please do exercise 5.2. So you go, please discuss with your friend. This is a group assignment. So it's a group assignment. So group assignment here. Okay, form a group consists of form a group. Form a group consists of 5 to 6 students. 6 to 7 students. A group of 6 to 7 students. Okay. Solve example exercise 5.2. Exercise 5.2. Solve exercise 5.2 on page 131, and 132. Then the part is exercise okay, so before that we have exercise 5.2. Then before this I have exercise 5.1 on page 122 and 123. So this is question 1 and question 2. Then this one I want you to solve question 3 and question 4. Okay. Then you go to chapter 4. Chapter 4 we have a few examples here. Chapter 4, please refer to exercise 4.2. Exercise 4.2. Page 92, page 92. Okay, solve question number 5, question number 5, and question number 6. Okay, and please submit to me or send to me through email. Okay, I give you a week to solve this problem. So now is 28. So please submit before. Yes, email to me. Email before 7:28. It's before 6th of July. It's 6th of July. 6th of July 2020. A group assignment. Form a group consists of 6 or 6 to 7 students and solve this problem as a group assignment. You can email to me. Okay? You can write or you can type, handwritten or you can type, and then convert to PDF file, and just email to me before 6th of July 2020. And next week, I'll give you a test. Next week there is going to be a test. Next week there will be a test. So the test will be on the test is on the 4th of July 2020. It is on Friday. So these are at home test. So open book test. At home test. So in other words, these are open book test. Open book. You can refer to your book. You can refer to your notes. These are open book test. The test will be held on Friday. So I'll give you this test started at 9 p.m. at night, 9 p.m. to 12 p.m. Friday, 9 p.m. to 12 p.m. Okay, so you are given 3 hours. 3 hours to solve this problem, 3 hours to solve this test, 9 p.m. to 12 p.m. Okay. And submit to me before 12 p.m. So you can refer to the test question is on My Guru. You can open My Guru to download the test questions. The question will be open on 9 p.m. and must be submitted before 12 p.m. And these are at-home test, chapter 4 and chapter 5. Chapter 4 and chapter 5 of my book. Okay? So chapter 4 is on the random variable property function. Chapter 4 is random variable property function involving discrete and continuous. And chapter 5, this chapter 4 And chapter 5 is on the expectation, mathematical expectation, mathematical expectation. So the question is the objective questions. Say objective questions. The question is objective questions. Okay, objective questions. So the test is on 4th of July 2020, 9 p.m. to 12 p.m. So 9 p.m. to 12 a.m. 12 a.m. It's not 12 p.m. 12 a.m. 9 p.m. to 12 a.m. 12 a.m. So I just put this 9 p.m. to 11:55 p.m. Don't confuse that. 11:57, around 3 hours, 2 hours and 55 minutes. You can download the questions on My Guru, and then the answer, you can submit the answer through My Guru. The at-home test, open book test, the topic cover is on chapter 4, random variable property function for continuous and discrete, and then the mathematical expression. The question is on based on objective questions. Will be multiple answer, 4 multiple answer, choose one. And then the time duration is 3 hours. That's all for this week. This is a week 10 assignment. Thank you very much.